show you guys how easy what you guys just said is. Like the heart and the bladder.
The bladder, you gotta do like the expansion of the cells too.
So here's what we're talking about today. What do you think a periodic function is?
It's only occasional.
No, that's not what periodic means. It doesn't mean occasional.
No.
Okay, there is periodic table. It's that's why it's called periodic. But what does the word periodic mean?
Why?
Huh? What? You're on the right track with frequent. But if I say something is periodic, it's a function that repeats.
Intervals.
In intervals. Now, a periodic function has a cycle and a period. If I say something repeats, what's the period?
There's gotta be a period of time.
Yeah, it's basically a period of time. Or it doesn't have to be time per se. We just say it's the length of a cycle. But what's a cycle? A cycle is the part that repeats. So, does a heart repeat? Yeah, like it always repeats, right? What's the cycle then? That's the whole movement of one contraction, right? So that would be one cycle. What's a period? Well, that would be basically the length of that cycle, or like you could talk about beats per minute and things like that, right? First hour, I want to talk about health class. So what direction do you think we went with periods and cycles? There you go. Like that's why they're called periods. They repeat themselves. What's the period? That'd be the month, right? The cycle would be the whole pattern of the whole month. Like, yeah. So now you've got, the yeah, the period is the amount of time, right? That's why they're called periods. That's why we call them cycles, right? It's weird how they came up with these names. Craziness. So in math, we end up we're talking about all these trig functions. Trig functions are periodic, and they're periodic for a reason. And that reason is very, very evident. As soon as we start talking about this diagram again with this thing. Why are these trig functions going to be periodic? Because not only, like sine right here is equal to 0.65. Is there going to be a spot where it equals another 0.65 somewhere else? Yeah, it's over here. And then it's going to be negative 0.65, negative 0.65. But that's only for one rotation. What's going to happen after one rotation? It's just going to repeat itself. And then it's going to repeat itself again. And then it's going to repeat itself again and over and over and over again until infinity. And it just becomes a repeating cycle. All of our trig functions are going to be periodic because they're just going to repeat themselves over and over and over again. Now, what makes a periodic function, like what do they look like graphically? Is basically if you have any pattern at all, is this going to be periodic? Why? What is, so let's say this is 0, 1, 2, 3, 4, 5, 6, 7. How did I do that? I've never made that mistake in my life. Never. Okay. So that's 3, 4, 5, 6, 7, 8. What in the world am I doing here? Dang it, I erased the wrong one. Ah! Okay. I'm trying to put a number on each one of these peaks. So 1, 2, 3, 4, 5, 6, 7, 8. That's working. 9, 10, 11, 12. All right. So my question to you first is, what's a cycle? The cycle is the pattern that's repeating, right? So what's the pattern?
It's up, down,
Looks like a what?
up, down.
Looks like an M, right? It's the M. This, it's a crooked M, but it's an M, right? Like that's the cycle. What's the period length? 4. Why is it 4? Because that's where it repeats. Now, technically, the cycle is not necessarily the M. The cycle is any length of, in this case, 4. Because the pattern could also start here. And the pattern would go down, up, down, up. Is that still a repeating pattern? Like if I took that orange diagram and copied it and added it onto here, wouldn't it just be the same thing? So it doesn't, there is no, in any periodic function, there's no official starting and ending point, right? But what has to be true about a starting and an ending point for all periodic functions if it's going to repeat? It has to be at the same spot. Here's why. Would this be a periodic function? If I did this, we'll go up to 2. Let's say I go up 2, down 1, up 2, down 1, up 2, down 1, up 2, down 1. Is that a periodic function? No. Why not? It's increasing. This whole pattern is increasing. If it's truly periodic, what has to happen every cycle? The exact same thing, right? If I take this portion and copy and paste it next to it, is it going to be right here? No, because it's increasing. Wherever you start, you have to end, right? Like, girls aren't, like, think, okay, girls, this is a nightmare situation, right? If your periodic function were increasing every single time for your entire life, like that's just torturous to think about, right? Like that's not going to be periodic then, right? That's going to be a bad thing, right? So, yes, periodic functions, you know they're going to be periodic because they got to start and end in the same place. And that's also a way you can figure out how long a period length is pick a starting point, any starting point, okay? If that's your starting point right there, okay, then you should be able to find the next point where you're at the same length, same spot, in 1, 2, 3, 4. That's going to be a period length of 4. Okay? Does that make sense? Now, a couple other things that periodic functions create. One thing that periodic functions create is symmetry. What's symmetry?
Whether it's the same on both sides.
Same on both sides, right? You can fold it in half, right? Now, there are 3 types of symmetry. There is x-axis symmetry. There is what we call y-axis symmetry. And a weird one that we call origin symmetry. Now, what is symmetry? You just said it's the same thing on both sides, right? So here's my x-axis symmetry. So what that means, if I have a point here, where do I also have to now have a point? Same side on the opposite side of the x-axis, which would be right about here, right? X-axis symmetry, if I had a shape that looked like this, what's the overall shape going to have to look like?
A diamond.
It's going to end up having to look like a diamond. Agreed? Easy? Now, same idea, y-axis symmetry. If I have a point there, where else do I have to have a point on y-axis symmetry? Other side of the y, right? So doing the same kind of exercise, if I have that shape there, what's this overall shape going to end up looking like? An M. Because you have to have this peak and then another peak, you'll end up looking like an M, right? Now, origin symmetry is a little different, but it works the same way. If I have a point here, I have another point on the opposite side of the y-axis. So what do you think I have here? If I have a point here, I have another point on the opposite side of the origin, meaning it's going to be down here. If I have a shape that looks like this, then I'm going to have a shape that looks like that. That's origin symmetry. Okay? Points get reflected across the origin. Cool? Yup. So, let's talk about origin symmetry a little bit more, because this is a new one. X and Y axis symmetry is easy. Origin symmetry does get a little bit kind of weird. Let's say you have a few points in this kind of curve, right? If you reflect a number on the origin, across the origin, it stays in the same spot. This point is going to just come to right here. This point is going to come to about right here. This point is going to come over here. You're just basically, if this point over here is at 4, -5, instead of going left 4 and down 5, you're going to go right 4 and up 5. So that point, boom, would get reflected right to there. And you'd end up with a curve. I missed it, but you get the idea. Something like that. Make sense? Easy so far? What's periodic? Repeats, right? X-axis symmetry, easy. Y-axis symmetry, easy. Origin symmetry, easy. All right, here's the game plan the rest of the week. Today, I just wanted you to learn these little things. Tomorrow, I want to show you about odd and even functions. It's not hard. And then we're going to spend the rest of the hour just doing some practice problems on symmetry, periodic, odd and even. I'm hoping you guys get all of that done in class. I don't want to give you homework for the weekend. If we don't get it done in class, we'll talk about it. We'll see. Maybe we won't make it due on Monday. Maybe we'll do it on Tuesday or something. So, fair enough? Just, it's a counseling, mental health weekend. So,